My name is Luke Dunkley, and my net ID is LPD21002, and today I will be talking about the Gnome Sort algorithm. Now, where does this algorithm come from? Gnome Sort is based on the concept of a garden gnome sorting his flower pots from smallest to largest. He starts at the beginning of the line and looks at the flower pot next to him and after him. Is the next one larger? If so, he will move forward in line by one spot. If the next one is not larger, he will swap the smaller pot in front of him with the pot he's standing next to before moving backwards in line and checking the pots again. He will keep doing this until all the pots are sorted from smallest to largest. Now, how does this algorithm work? First, we will initialize the position to 0, and we will increment position by 1 if we're at the beginning of the list, or if the next item in the list is larger than the current item. When the next item is smaller than the item at the current position, we swap them and decrement the position by 1. And we repeat this process until that item is now larger than all of those before it. And then we repeat all of these steps until the list is sorted. Here is a visualization. As we can see, at first the list is in 15310. And we start from the beginning and we find 3 to be smaller than 5, so we swap it. And then we have 13510. From here we see 1 is smaller than 5, so we swap the 1 and the 5. And then the 1 is then smaller than the 3, so we swap the 1 and the 3. Now we have the list at 11350. And as we can see, 0 is smaller than 5, so we swap the 0 and the 5, and we keep swapping the 0 until it is moved to the beginning of the list. And then we have a sorted list using the Gnome Sort algorithm. Here is my implementation of Gnome Sort. As you can see, I initialize the position to 0, and while the position is less than the length of the list, if the position is 0, or if the item in the position is larger than the item before it, we move forward in the list by one position. If the position is not 0, and the item we're at is not larger than the one before it, we swap the items and move backwards in the list by 1, decrementing our position. Now, since we check every item with every other item, the code is going to have a time complexity of O of n squared.